Yeah?
I think we're good to go.
Perfect. So, hi everyone. How's your week been going?
So good.
Good? Awesome. Learning lots? Getting lots done? Maybe? At least having a good time? Cool. So I'm not sure how these morning lectures have traditionally gone this week, but I'm going to give you I'm basically going to run through slides I made for something else, and talk to you guys about a tool. Then I'm going to attempt a live demo, because we know those always work, and show you how to use this tool and some of the value that it can hopefully bring to your guys' lives in the next few weeks, and maybe beyond, hopefully. So let's see. Here's just a bunch of people that have contributed to this tool. It's called Boutiques, and I'll explain in a second. So first of all, who here has ever tried to, but based on where we are, I expect the answer to be obvious, process a piece of data in any way, shape, or form? It doesn't have to be a brain data, anything. Who has done a thing to data? All of you, awesome. Who here found that it always works perfectly on the first try?
Sure.
Really? Wow. Can you come up here and teach actually instead? That's impressive. Yeah, magic. And let's see, what are some of the sources of issues? Sometimes, do people have installation problems? Do people have documentation interpretation problems? Maybe documentation was missing or not clear. Yeah. Do people have maybe missing data? They aren't testing it on the right types of data, but it was hard to distinguish that. Maybe this one you're not quite there yet, but this week potentially you're getting there. So anyways, one thing that I'm going to talk to you about again is Boutiques, which is this tool that we use, or that was created by Tristan Glattard, who can't be here because he's on vacation this week. And the package is maintained by him and I. What it tries to do is it describes how tools can be run. And it doesn't just describe them, simply like, oh, here's the default set of parameters. It describes exhaustively how to use a tool and how to interact with it. It includes things like tests. It includes things like exit code, so when it fails in certain ways, it can mean different things and can be interpreted different ways. And what this allows you to do is kind of share and consume and kind of deploy your tools at a really large scale quite easily. So I'm going to quickly talk about, actually I'll come back to those. So I'm quickly going to just talk about this kind of schema. So who here has heard of a JSON file? Show of hands. Cool, so that's most of you. So JSON stands for JavaScript Object Notation. It's a fancy way of saying everything looks like this. And basically you have curly braces, which similar to Python are a dictionary, and square braces, which similar to Python are a list. And then you have different values, in each of these places. So this is the smallest Boutiques descriptor that we could make. So we have the tool name. It's called Echo. Whoops. The version we'll say 1.0. This is the tool description. This is the command line. So this is an important piece right here, this command line. So this is how the tool is actually being used in this case. So echo this thing called param, and then we're putting that in a new file called output.txt. This is using whatever version of the Boutique schema. And now we have a few important fields here. So we have inputs and output files. So inputs. We're going to call an input called param. Its name is parameter. Who would have thought? And then the value key is param. So notice this corresponds to the piece up here in our command line. So these are matching, which means that essentially when you provide as input something called param, something at the ID param, it will be substituted in this location for this tool. And again, I'll explain how all this works in a second. And then we have now this output files container, which says, again, it's a list of things. We have one of them here, and we expect one output file that is in the path output.txt. So again, from you guys learning Bash last week, what you may know happens is, again, we say echo whatever we put in the container param, this chevron to a file. Whatever param is will end up in the file output.txt. It'll create a new file and it'll put it there. So essentially, this is the smallest descriptor we can make. Does anyone have any questions so far about how this is laid out? Yeah.
Is there a link with the echo path?
Sorry?
Is there a link with that and with the echo write echo on bash?
Yeah, so it's the exact same echo.
Okay.
Yeah, so this is so that's a good question. So this is a bash command. The command itself right here, this echo, is a bash command. So what this essentially, again, what boutique descriptors summarize is how to run a command line tool. So that can be a Python script, it can be a MATLAB script, it can be a bash script, it can be anything else. And again, the point is it's trying to standardize the way these tools are documented and can be interacted with so that you can seamlessly jump from one to the next. So again, if you're trying to use, say, fMRI prep, or you're trying to use NIAC, or you're trying to use, I don't know, AFNI, it doesn't matter so much what interfaces you're used to dealing with, how you like to put your flags on the command line, as long as you have the description of the way parameters are expected, and you provide them in this, again, a format compatible with the descriptor, your tool will run and be able to be validated and so on. So again, here's just a list of some functions that I'll explain in a pretty figure in a second, but before I do that, I just quickly want to talk about or introduce this concept of the FAIR principles. So we've been talking a lot about reproducibility over the last couple of weeks. Who here has heard of the FAIR principles? FAIR, F-A-I-R. Cool. So I think they were mentioned maybe last week. So just to remind you, the FAIR principles say findable, accessible, interoperable, and reusable. So, in a perfect world, these were originally proposed for data, making your data sets findable, so having them hosted somewhere that's persistent, accessible, so they're, accessible through non-proprietary means, interoperable, so, they're adopting some standard that can be shared between different resources, and they're reusable, so, they're sufficiently described and sufficiently present that they can actually be consumed meaningfully. So this was, again, originally made for data sets, and it would be nice, though, in a perfect world, that all these things would also apply to the tools we're using. So, our tools were interoperable, tools were reusable, accessible, and so on and so forth. So, again, making data fair has been done a million times. And with tools, there's different pieces that we have automatically. GitHub exists. GitHub, allows us to have findable code, kind of. There's no guarantee of persistence. I can just go and delete my repository tomorrow if I want to. So that's kind of there. We have Sphinx Documentation, which I'm not sure if you guys have played with yet. It's a plugin or an extension for Python that allows you to build these really pretty documentation pages. If you haven't built Sphinx Docs before, I'm sure you've interacted with them at some point on the internet. They're everywhere. And so, that makes things accessible. There's like a relatively standard way to interact with documentation. BIDs and BIDs apps make things more interoperable because, there's these standards that are being adopted. So you only have to start to specify, arguments in a certain way. You're starting to have to reduce how much you're learning there. And, containers such as Docker and Singularity really help with the reusable bit because you're packaging your environments kind of tightly. Yep. Yep.
I remember we talked about Amazon data server.
Okay.
Where everything is, I guess.
Okay.
Is it like where is all the repo of GitHub? Is it on AWS?
Oh, like where do they actually live?
Yeah.
That's a good question. I mean, I would be surprised if they were there because Microsoft owns GitHub. So I would imagine that Microsoft would host them.
Maybe I'm confused. Okay. So no, just my thing is to say that today it's free.
Right.
But it's not free to have data somewhere.
Right.
So who is paying for that?
Right. So Microsoft owns GitHub. So
Okay.
Microsoft, before GitHub was paying for it, I don't know if they were profitable. I don't think they were. Do you know if they were, Pierre?
I don't know. It's a good question.
But I know that Microsoft foots the bill now.
And it's a worry. It's a worry to build on top of those big companies. I feel
Right.
like it might turn out into Facebook at some point. Facebook was
Right.
an awesome thing until we discovered that they were maybe not so great.
Oh, I thought you were going to say until we discovered that everyone's parents were on it. I'm kidding.
I'm not sure this is a risk with GitHub.
No, I don't think everyone's parents are going to just jump on GitHub. No, so that's absolutely a worry. So one thing that we'll actually talk about kind of tries to avoid GitHub for findability as well, with a solution that at least I will say seems like it'll be more ethical and sustainable, and I think most people would agree. So again, what we have inside Boutiques is a bunch of tools that kind of bring you closer to achieving these FAIR principles for your tool or for any other tool you're trying to consume. So I'll just go shortly through this list and again go to the pretty picture on the next slide that you've seen me glimpse at a few times. So you can import tools from existing other standards, including just arg parsers if you've written a Python script that accepts command line arguments. You can create them from scratch. We have a lot of tools that help with that. You can integrate tests and run tests that have been integrated with tools. You can publish descriptors. You can search for published descriptors. You can print an accessible version of the descriptor, which shows the documentation of it extensively, and can be a really nice way to learn what the tool is actually doing and what all the parameters mean. You can simulate the execution of a tool. You can generate example parameters. Even this list, when I made this a few months ago, is out of date by about 5 commands that have been added since then. That really, again, go towards facilitating like the accessible re-execution of code. And so essentially the workflow, if you are, depending on what you're doing, you may enter this workflow at different stages. But let's say we're in BrainHack school, we're all probably making something cool, even if it's a new analysis or a new pipeline or whatever. So we're going to say that we're entering the workflow on the furthest spot on the left. We're starting at phase 1, create a descriptor. So again, let's say we've written our tool with Python. In that case, we happen to be helped out. We can create an arg parser. There's also importers from, say, NiPipe interfaces or from common workflow language, Workflows CWL, if any of you have heard of it. There's an automatic descriptor generator for BIDS applications, if anyone was remembering BIDS apps from last week to go along with BIDS datasets. And there's, I think, another couple form of imports as well. So right away, we can create our descriptor if we've just written a tool. And maybe it'll require a little bit of tweaking because, as an example, in Python arg parsers, we don't generally specify the output files that are created. In your Python arg parser, you specify the input arguments you need. So what you'll probably need to do is add some things, test it out, continue to build on it. But that's, again, should be relatively straightforward, and we'll go through it in a second. Yeah. Kind of. So a descriptor in this case, so the question was if you write a README as a descriptor. I would say it's a description, but it's not a Boutiques descriptor. So a Boutiques descriptor, again, is following a specific language, which is what's defined here. And I'll explain in a second again how, and I'll show you in a second with my terminal, how we can generate these descriptors and look at them and use them. And we'll run through like a BIDS example doing that. So Bosch is the Boutiques shell. It's the Boutiques command line thing. Yeah. Yeah, so it's basically how you interact with the Boutiques tools. So Boutiques is 2 things. It is the way we describe tools, and then it's Bosch, which is the tool that has a bunch of instrumentation around these descriptors. Does that make sense? Perfect. So then now, after we do our creation, we have our descriptor. So what we can do is now we can publish it. And one thing that you may see here is we published to Zenodo. So who here has heard of Zenodo? I'm not sure if anyone mentioned it last week. Cool. So Zenodo is this great repository that's made by CERN. Essentially what they did was they needed a platform for internal data management at CERN. They have this kind of large set of experiments around this thing called the Large Hadron Collider. Not sure if you've heard of it. It turns out it produces lots of data. And they needed a way to organize that data, have it be persistent, have it be managed, have linking between different collections of data. So they built this wonderful service. Now, they realized, this tool might actually be useful for people. So we should make an API for it, open it up to the public, and let people post their data there. So this is, again, a freely available, publicly hosted service supported by CERN. So it's not tied to a company. It'll be hopefully outliving all of us. And then again, we can post our repositories there, and they're publicly available, and they're completely persistent. So just like when you publish a paper, you get a DOI, a digital object identifier, that is immutable. It will always be the same. It'll always point to something that has a record of your paper. These are the exact same. You publish your descriptors here, and they are persistent. And that means that even if you say, you want to make it deprecated, you want to say this tool no longer works, you can update it. but your tool will exist in this repository. Someone will be able to go back in 20 years, say, I want to replicate, so-and-so's paper using this tool, this version of it. I can find that descriptor in Zenodo, and I can, get the tool that's associated with it. Is basically the idea. So yeah.
Is there a space also for data in Zenodo? Or it's just
There is. Yeah, there is. So one thing that's actually not covered here that I'll explain in a second is, or actually I'll just explain it now, it seems like the right time, is Bosch also instruments wrapping executions. So when you run a tool using the boutique shell, what it'll do is it'll keep track of all the files you provide, the outputs, the exit status, the logs, that kind of stuff. And you can also publish all of those records up to Zenodo. So then you can build this really rich computation graph of all the things you've done on every tool and their relationships between each other. But again, of course, so that's just like logs. You can put data files up there too. It's one of those services like Open Science Framework and Figshare and places like that just allows you to persistently store data. Yeah.
Compared to DOI,
Yeah.
do you think it has to be, or it's going to be the reference of each time someone builds something kind of really useful for all the community and has to be kind of published? Is it the way it's going to be for anyone? I mean, the reference to do, people just working on their side in GitHub and blah, 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 and they don't do it.
Yeah, I think I understand. If I answer the wrong question, just rephrase. But so essentially, as I understood the question is, like, is this a thing that we're recommending for everyone to do some type of publishing of their tools? Or yeah, and I mean, so there's already an integration with Zenodo from GitHub, actually. So you can update, you can have it set up so it's automatically when you update your repository on GitHub and you make a new release, it'll automatically create a new DOI for your release on Zenodo. So this is what's called a webhook, where basically you trigger Zenodo to be listening, or you trigger GitHub to tell Zenodo to pull when it's ready. And so this is a thing that already exists. So what this is trying to do is basically not just have the tools themselves be stored persistently, but again, an accessible form of executable documentation on them. So it doesn't matter if the tool itself is, perfect and up there, if the documentation is in, say, another language. If there's something like a boutique descriptor that's well written with tests and things like that, I can still simulate the command execution, and I can still actually use the tool as well. Effectively. Does that kind of answer your question?
Yeah.
Cool.
Sorry, Greg.
Yeah.
So are you pulling tools that are out in the world in
Yes.
this then?
Yeah, so I'll show you guys in a second. Let's see if my terminal wants to load. Cool.
Maybe you're going to cover that, but your description include containers? Is that?
So right now there's a container field. I can't tell if that's too wide. Cool. There's a container field in the descriptors, but there's no actual container themselves. That's something that we're managing separately right now, because Docker and Singularity behave differently in terms of what they actually give you as a container. But yeah. So one sec. What I'll do: Bosch search. So what it did is just showed 10 of 50 results that popped up. And essentially you see the Zenodo ID, which is their unique identifier. Again, they're like DOI. The tool names and descriptors, and they're just sorted, I guess it looks like by downloads. And I think there's another sorting feature too that isn't showed up here. So cool. So now let's say what we want to do is Bosch example of this tool. So I want to get an example set of commands for that tool. So let's see what happened here. What did it give me? On instance, blah, 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 blah. Woohoo, MD5 reference. My goodness. Live demos, right? I can't even figure out where the command starts. It's longer than my terminal. Sweet. Let's see. That's funny. This is a fresh version of Bosch I installed this morning just to see if it was going to work, and it seems like maybe not. What I'm going to do is quickly check out my branch from that I've updated with a patch to, I think, this problem. But let's see, gchar boutiques. Git branch A. In case you guys are still learning your GitHub stuff, what I'm doing right now is, again, you guys have learned about branching. The -A flag shows you all branches, not just the ones you have a copy of locally. So what I probably should have done is that, and I could actually read everything in this list. Now I can see which one is the branch that I actually wanted to do. GK publish patch. So maybe that's the one I want. I think that's the one. So git checkout GK publish patch. What will happen here, everybody who is remembering their GitHub?
You'll go to this branch.
Cool. Awesome. And it says your branch is behind by one commit. This can be fast forwarded. So I happen to have an alias set up where GPL for me means git pull. So I did that. Great. It gave me a thing. And now I can go back and I can try. Let's see. Where CD tools Python pip. I'm going to install this version. Does anyone know what this version of installing a package does? So first of all, what's pip?
Yeah, it's Python.
The Python package installer, yeah. And then install is what you want it to do.
Yeah, and the E is for edit.
Editable, yep. So that means essentially you can install things that are in like development mode. That means that every time you make changes to them, you don't need to reinstall them. The changes will automatically be reflected. And then dot means the current directory. So I'm installing my current version, essentially whatever's in this directory. It expects to find a valid Python package as an editable library so that if I find more bugs throughout the course of this demo, I can just quickly patch them and you won't even be the wiser. So let's try this again. So let's do Bosch search and see what happens. Cool. So now let's first do Bosch pull, and I passed the DOI. Great. So now what this did was, I think it's in cache, boutiques. So what this did was it put down some descriptors I happen to have other ones already there, but it pulled down this DOI, this descriptor, into our cache directory in a folder called boutiques. So this DOI was this guy. So let's figure out where that one is. So we are going to VI. So does everyone remember what VI is? It's
VI is editor of the devil.
It is the editor of the devil according to Emacs humans. It is your best friend according to JB and I, and it is something most of you should really avoid if you care about your sanity. I'm actually going to do less instead. Actually, will I have syntax highlighting in VI? Maybe I will. Let's just do that first. Okay, that's not awesome, but let's change the color. Oh, that's horrible. It's way worse. That's better, kind of. Sweet. So, lovely. So again, here, this is the test tool that we made. It has test author, example tool 1, a bunch of things, config file, string input list, blah, 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 blah. Cool. So this is just clearly some example. And what we see here, to answer kind of what Pierre was asking a second ago, is this field that's called container image. So here we can specify our, say, Docker container that corresponds to our tool. So it's a type of container is Docker. Have you guys learned about singularity? Kind of. Okay, so singularity basically, well, so first of all, what do people, can someone tell me in 2 sentences what Docker is? A container, awesome. What else? What is a container? It's not my Tupperware.
It packages like minimally your operating software and your lists your dependencies that you use.
Cool. Exactly. That's a great summary. So it packages your dependencies in your software in this minimal little bundle, as small as we feel we can make it, and allows you to run them. Great. So one limitation of the way Docker does this is it relies on something called a daemon, which for all intents and purposes we'll just call a service. And so a service is sitting on your computer, and then when you tell it to do things, when you say Docker run, what that command does, it says go to the service, tell it I want this image somewhere else, pull it down and run it for me. Now, in order for it to work this way, services have to be run by administrators on machines, which means they have access to everything. They have access to change and modify and delete, importantly, delete any file, which is dangerous. And especially if you have, supercomputers that you're trying to share. You have, say, like Compute Canada. It wouldn't make sense for me to be able to use Docker on that machine, because if I can use Docker, then I'm running a service through the administrator, which means that I can pretend I'm an administrator, which means that I can then do anything on that machine and break it for everybody else or lock everyone else out or whatever, or mine Bitcoin. So what Singularity does is it essentially gives you it does the same goal, it serves the same purpose as Docker, but it gives you a way to do this that is not through the administrator. So it's more secure, but it comes at the cost of being only available on Linux distributions. And it's quite experimental still. They just got venture capital funding last year, I believe. It was started out of a lab in Berkeley, and has really very quickly taken off and is pretty much on all supercomputing clusters in North America that I know of. So it's a very interesting tool that you guys will potentially play with more. And it's also nice because you can automatically convert your Docker images to Singularity images, because they recognize that they've more or less built their tool to be a second-class citizen to Docker. Docker is the one that everyone in industry uses, but if you want to use it on a shared resource, Singularity is the way to do that. So anyways, that's a thing that we'll talk about later. So you can have a Singularity or Docker container. You say where to find it, and you can say container options. So for instance, when I launch this container, I want it to have these parameters. So again, in this case, we're setting the environment variable so that our home directory is the same as our current working directory. So then we say deprecated. So in this case, this descriptor has been deprecated. That means it's no longer valid, which probably explains why the crash that happened a second ago when I tried to run an example with it. But I'll confirm that in a minute. Then we have description. We say where the descriptor is found online. Again, more environment variables, error codes. So in this case, we know when the command dies and gives you an error code 2, what that means in this case is the file doesn't exist. I forget, did we tell you guys anything about error codes last week? No?
About what?
Error codes, or exit codes. Cool. So when a command executes, it will do whatever it's doing. It'll sometimes give you a file back. It'll sometimes print some text. It'll sometimes throw an error, which is basically printing a different type of text. And what it'll always do is it'll have some exit status. And if there was no problem, the status will always be 0, or at least that's the convention. And if there's a problem, the status will be non-zero. Any number up to 255, I believe. And so then basically, let's see. Cool. So actually, I'll change the color of my terminal so you can see that more clearly. Does anyone notice the difference in these two? The color. So I happen to have set up my terminal such that when something returns a 0 exit code, it gives me a blue $, and when something returns a non-zero exit code, for instance, command not found, it gives me a red $. This value is stored in this thing called, or this environment variable that is essentially the question mark. So again, what I can do here is say ls, and now what is the exit code of that previous command? 0. Now I can do, again, some garbage command, which I really hope no one names the tool that. And then I can look at the exit code for that, and that's 127. So again, exit codes can tell you a lot. So again, in Bash, it just so happens that 127 is the exit code used when a command is not found. So what you can do in your specific tools, and what a lot of people often do, is specify specific error codes for specific failure modes. So in this case, again, we've said that exiting with status 2 means the files aren't found. Does that make sense?
Yeah.
Cool. Does anyone have any questions so far? Cool. So let's see. We can also have groups. I haven't talked about these yet, but I'll go back down to inputs first, and then we'll come back to that. So again, as I was showing on the command line, there's a bunch of different types of inputs you can have. So in this case, we have, what is the name of this? String input list. So you can have lists of strings. So for instance, say, again, you're trying to, you have a connectome or a functional time series, and you're trying to extract the time series for certain regions. You could provide a parcellation and say which regions you care about. As an example, you could provide a list of regions. That would be one way, like type of parameter this would be appropriate for. You can have a string input, so just a single string that just says, a threshold you want to use, or actually no, a threshold would be a number. You could say, I don't know, a base name that you want your output files to be saved as. You can have, again, lists of inputs. You can have choices, so what we call enumerables. You can have configuration files that are written and all this kind of stuff. So basically every type of input parameter you can have, we've made an effort to try and describe here. Not necessarily in this descriptor, but support in the schema. So then again, output files are defined here. You can have different templates so your output file name is dependent on, I have this line right here. Your output file name is dependent on, not what I want to do. There we go. Is dependent on your input values. So again, say you provide some threshold, your output file name again will be automatically generated with, say, that threshold value, and so on and so forth. To go back up to the groups, say you have two inputs, and I want someone to potentially provide me either the flag, let's go back to the parcellation example. Say I want to, again, extract the functional time series for certain regions. I provided some atlas, and I either want them to pass me a value that says all, or like use all regions, or I want them to pass me a list of regions they want me to care about. But those two shouldn't coexist because it doesn't make sense to. So you can then specify that these are mutually exclusive, which a mutually exclusive group flag, and again, have all this stuff. So what all of this rich description allows you to do, sure, it's kind of duplicating logic that may exist within your code, but what it allows you to do is actually validate the way your code should run before deploying it. And so who here has ever used Compute Canada? Okay, so a few of you, probably more of you will in the coming weeks. So one of these things with big shared resources, or maybe you'll find this even when you're not using a shared resource, but just launching any pipeline, is that things often take a long time to get started, to get given resources to use, and then can often take a long time to run. If you're processing a lot of data, or if your data is really big, or if your pipeline is just long, it may take a lot of time for things to happen. Which means that you want things to fail as early as possible. You want them to, if they're going to fail at all, you want that to happen before you even run the tool, so that you can fix it, and then you aren't wasting time, you're not wasting resources, and you don't have to duplicate your effort. So basically what Boutiques allows you to do is pre-execution validation of your commands. So instead of submitting a job to the scheduler, waiting for 2 days, it gets put on the CPU, it runs for a day, and then it chokes, Boutiques would catch that before you even hit submit, because if you make a good descriptor, because it's doing this validation of arguments that is kind of front loaded. Does that make sense?
Right.
Yeah.
Can I ask, it seems to me that somebody who writes a tool will think that they have written it in a way that makes it already accessible, and all these things that you're saying that this does.
Sure.
And so what motivation have they to sit down and do all this extra work of making this JSON file or wrapper, whatever?
Yeah.
I'm just,
Yeah, so that's a great question. So the question was, in case anyone didn't hear it, what motivation maybe I needed to dot McGill in there. The motivation, or the question, sorry, what motivation do people have for actually doing this extra effort to make their tool more accessible when I'm sure everyone believes that their tool is already accessible? So I'm just logging into CBrain. Some of you guys may have heard of it or been introduced to it at some point. I'm just going to pull up some arbitrary data set. This one seems fine. I'm going to click some tool. I think that might be a thing. I'm going to launch an execution, and I'm just quickly going to get you to a form. Let's go with bidzap fMRI prep, because I know you guys know what that tool is. And select server and version. I'll just pick one and launch. So, it needs a bids data set. Okay, I'll pick a less strict tool. Select server and version. There we go. Cool. So essentially what this tool is, this just happens to be a diffusion connectome estimation pipeline that I wrote in my master's. It's has a bunch of inputs you can select. You can provide a DTI image, B values, B vectors, gradients, whatever. And then you can launch the tool. This form on CBrain was dynamically generated because of the boutiques descriptor. No one had to code this. No one had to make this. I described my tool, and then a platform was able to automatically interpret it. It will be able to do validation before it submits the jobs, and it will be able to do like kind of garbage collection and move files back to the right places and provide them to the user afterwards. So while I may have written a tool that I believe to be super accessible for anyone who knows MATLAB, when I wrap a description like this, what it allows platforms and things to do is interact with that tool in a completely language agnostic way, in a completely automated way. And you kind of get this scalability and deployability for free. And so CBrain isn't the only platform that supports it. Now there's a few other things. Virtual imaging platform in France supports boutiques. There's a tool that I made and use pretty much every day right now called Clouder, which is basically a serverless version of CBrain. And it uses boutiques. And so there's various...
Who made boutiques? Where does it come?
Tristan created it, and I'm like the co-maintainer with him now. So it's made in Montreal.
And what is the relationship with Bits apps? Because what
Yeah.
you describe sounds a lot like what Bits app is.
Right. So the question for anyone who didn't hear is, what's the relationship with BIDS apps? So BIDS apps, as a refresher, are essentially a standardized way of describing tools. So you say your tool has to have these arguments, and then you accept a BIDS data set as input, and voila, then your BIDS compatible. Great, go forward. So the problem with that, so essentially that's the model saying everything should try and fit in this box. And what we're saying is, not all tools make sense to fit in that box. Some tools don't need a BIDS data set, they just need a file. They don't care if it's a nifty file, a diffusion file, a functional file. If all I'm doing is say, like stripping the header or something like that, I'm not sure why you'd want to do that, but just stripping the header or something like that, you don't necessarily need a BIDS data set. So what Boutiques is trying to take the approach of is, rather than fit your tool into a box that may be a little forced in some cases, just describe your tool well, and then we can use it anyways. And just for a peek behind the curtain, we're actually in the process of creating BIDS app standard 2. And so it's led by Chris Markowitz and I, and it will just be boutiques, basically. So the next version of BIDS apps is, again, the expectation is the command line, the tool can work however you want it to work, as long as you have a certain flag in your boutiques descriptor for how to access or where to put your BIDS data set, where to put your output directory, and so on and so forth. It doesn't matter how your tool wants to accept those arguments. It matters that your descriptor accepts them in a standardized way. So that's the thing that we're, again, working on now. And that'll make it a lot easier, a lot more transparent for users who want to consume BIDS apps. Does anyone have any kind of questions there? I can share that extension proposal with people if they want, because I realize that tool use standards should be influenced by the users of tools, not just the makers. Cool. So I'll just quickly hop back here for a minute. So anyways, I've just kind of shown you the inside of a descriptor. And as I said, you can push these, you can search them. Oh, I don't think I showed you like keyword searching, but I mean, I'm guessing you can guess what it is. So you can do Bosch search, say diffusion. And again, it'll show you all the descriptors that are published right now that happen to use diffusion stuff. So for instance, this DiPi deterministic tracking one happens to be a thing. Again, I'll do Bosch example. Let's see if it wants to work this time. Ooh, it did. Awesome. Look at that. When I pass a non-deprecated descriptor, it works. Cool. So in this case, let's see. Let's also Bosch pprint Zenodo. Actually, I'll put that in a less container. Awesome. So this is the pretty print version of the descriptor that I said. You can get accessible documentation. It shows you exactly how the command line runs, all the arguments, gives you the description for it. It has some tags, tells you the name of the version of your tool, the name of your tool. This happens to be one that I have been working with this week. The recommended resources for launching it on your computer, which again is super valuable if you're trying to actually run it on a computer at scale. all your arguments, a bunch of things, yada, yada, yada. We can go through the whole list, shows you every parameter, what it means, the output files that'll be produced, and so on. So this is the version of documentation you get just from the descriptor. Now, again, what I just did was Bosch example with the same ID. And what it did was it essentially populated a version of what we call an invocation or an input file that basically says, here's a minimal working example of what could be a invocation file. Then it just generated random values. So here, b values, that's CPP. I just added an arbitrary extension. Of course, a bvac file or bval file shouldn't be .cpp. But it also doesn't necessarily need to have an extension, so we didn't put one in the schema. So bvec's diffusion image, output directory, seed mask, and so on. So then what you can do is, now that you have this little descriptor, you could put it into a file, my temp inputs.json, and I can do that, and I can replace values with files. So for instance, I happen to know that on my machine, I have, a data file here. Let's just pretend. Again, I really am, that is not valid bids, so don't think that that is. But anyway, so you can again just replace these values, and then what you could do, so you can save it, we can pretend that's right. We can do Bosch exec simulate, and I can provide my, oh whoops, I accidentally copied it. We can provide our descriptor, and we can provide our input file, and it'll tell you, here's the command line you generate for this tool. And again, then you can validate, does this make sense given my command, given how we're supposed to run it? Is this a valid set of arguments? Are things in the right place? So on and so forth. Is this the right place for my Nifty file? Whatever. And then when you're actually ready to launch it, I'm not going to do it right now because those inputs are all garbage. But you can do Bosch exec launch. I don't think I need the I flag anymore. And you'd run this, and then essentially your tool would run, and it would collect a bunch of data for you of that run. Does that make sense? So one thing, again, if you type Bosch help, it shows you all the different modes. So as I said, what it'll do after it runs, it will manage the execution data that you've just run. So what I can do here is Bosch data, and see what that tells me, and inspect, publish, and delete. So Bosch data inspect. Let's see what happens here. Okay, so here are a bunch of different data files I have. So let's look at, oh my goodness, that's so many. There are 91 unpublished records in the cache. Cool. So let's pick this one. That seems fun. So we're going to again go to our cache directory, boutiques. I think it's in the data subdirectory. And awesome. So it shows you the tool, the public invocation. So basically, this is the diffusion image that was done. Here's a hash of it. Who here is familiar with hashing? So essentially, hashing is a type of function that you can apply to a piece of data, and it'll give you a unique identifier of that file. So essentially, this ID right here is completely unique to this file. If my file had one bit, a tiny bit different in it, this hash would be different, which means that essentially this is a very succinct way to describe what this data file contained. And it's not reversible, so I can't just go back and get my data file from this, but I can at least compute the hash on this data, and then I download an image that I think should be the same image and verify that they are or are not the same. So the hash shows you, again, this is the name of my file, this is the hash of it, and it does this for every set of inputs that was used in the parameter, and shows you all the other parameters, then gives you the outputs, the commands used, the exit codes, the files produced, their hashes, and so on and so forth. So again, this is something that just boutiques will do automatically for you, and then you can also publish these. That was just sandbox stuff that's kind of useless, so I won't publish it, but I think I can get a help command. So then you can also publish your records, again, to Zenodo, the same way you'd publish a descriptor there, and have these be persistent that you can then cite in your paper. In your methods section, you can say all of my analysis are published under this DOI. or analyses are published under this DOI, and then people have a incredibly rich record of everything you did in your experiment. Does that make sense? Cool. Whew. Okay, what time are we at? Awesome, 8 minutes. So let's see, what else do we have that I haven't played with yet? So I kind of showed you how CBrain interacts with these tools. So I know some people have been talking about, or someone messaged me yesterday asking a CBrain related question. Again, if you want to, say, launch your tool you're making a pipeline, or you want to use a pipeline over the course of the class on a big data set, integrating it with CBrain or this tool Clouder, again, which is a thing that I made and pretty much sits right on top of boutiques. You can do that, and it'll help you interact with Compute Canada, which is nice. The preprint we've already shown. I don't think I've shown you test yet because my descriptor, the example one, I don't believe has it. But essentially what the test container in boutiques does is you provide an example set of inputs, an example set of parameters, and the expected output, both in terms of files and exit codes. And it will it'll run that command and verify that all those things are correct. And I think that is about it. Does anyone have any questions?
So, when you launch the execution,
Yeah.
If you want to run it directly on Compute Canada, for example,
Yeah.
Would you run it inside the bash script that you submit to Sloan, or is gonna be able to submit it by itself?
Right. So the question was, if you say want to run a boutiques tool on Compute Canada, would you just run it using the boutiques command, or would you put that command inside your bash script which you've submitted to your scheduler? So if you're using Clouder, it will do the submitting to the scheduler for you. If you're submitting jobs to the scheduler yourself, you would want that job to be your bash command, or your boutiques command rather. Let's see. One thing I'm also going to do is code. Do you guys remember how to create virtual environments? What's the command? Actually, you guys have probably learned 18 different ways. The way that I do it is this library called virtualenv. I'm going to create one that will use, I think P is the flag, which is saying I want to use Python 3 and environment. I'm going to just create a Scratch environment inside this folder, and we'll see what happens. This happens to create a virtual environment for me. I'm going to show you how to install boutiques. It's pretty easy. It's pip install boutiques, but I want to prove it. And this is on Compute Canada, by the way. I just switched machines, as you can tell by the fact that it now says I'm on Graham. Whenever that wants to work. So close. In the meantime, I might just do it on my local computer. But what you can do is, pip install boutiques, and voila, that did all the magic for you. And again, then when you want to use it, if you don't ever remember where it exists, you can do pip show boutiques, and it'll tell you if you have it installed. And in this case, it did, and it tells us where it's installed. It happens to be installed in this directory, which is right, because as I showed you earlier, I installed it in editable mode, and this happens to be where my repository lives. And then from there, again, you can kind of go and inspect what you need to do. So again, in this case, if you wanted to look at the package more, explore what functions exist or things like that, you could just cd to this directory. Again, this is the case with all Python packages. They just won't be stored in that path. And then you can see everything that's there. So for instance, in this case, I could look at the setup.py and see what versions of Python it's supposed to work with and things like that. But anyways, you just install it with pip install boutiques. And of course, virtual environment is still taking forever on Compute Canada. It's been kind of slow the last few days. I might have been launching too many jobs on it and they got mad at me. Yeah, so the takeaway message basically from this, before I let you go in a minute and a half, is tools are really annoying to use pretty much always. I think everyone can agree with this. Tools will always have different standards, and every developer thinks that they have the latest, greatest way to describe a way tools should work, and everyone should follow their standard, which is that XKCD comic that was shown to you last week. You know, there are 14 competing standards. We should make one that unifies them. Now there are 15 competing standards. And so working with tools is often incredibly heterogeneous, and a ton of startup time is wasted on learning how tools work, like the APIs to tools, not even the underlying features. So then what Boutiques is trying to do is abstract that away, give you an automated way to explore these tools, get documentation that is printed in a consistent format, as you saw with the pretty print. It doesn't matter what language the tool is written in. If you have a Boutique descriptor and then pretty print that descriptor, it will look exactly the same. So you can always parse doc strings the exact same way. Again, it'll integrate these tools with platforms more easily, making them deployable for you, and allow you to, again, inspect and interrogate as you see fit. So Boutiques is trying to make it easier to do this reproducible, fair type of computing. And that's that. Thank you for your patience. Oh yeah, I canceled it. And if anyone wants, by the way, you probably also are wondering why this is here. When I've been doing various things in my terminal, so like if I check out the new branch, that changes, and you know, my $ stuff. If anyone wants these little things to add to their shell in Bash, I can also send these configuration files to you. They're fun to make, and I'll show you how to like mess around with it yourself, but they can be super useful. And again, I find it's also a good way to get familiar with how the shell works, how things are stored, what environment variables mean, and that kind of stuff. So if anyone wants to do that, I remember someone asked about like websites and things like that on Slack last week. I feel like this is another little like life hack type thing that would be fun to explore in case people have questions. And again, I can't tell you how many times I notice errors only because of the $, not because the help print message was actually helpful. Cool. All right. So now I guess it is, Pierre, what happens next? Do they just work?